Hey guys, welcome to Guys Teach Stuff. So, today we'll be talking about some physics, specifically 7Ka, different forces. So, what is a force? Well, a force is essentially an object's interaction with another object leading to a push or pull. So that might sound a little bit confusing at first, but it'll make sense, trust me. There are two main classifications of forces: contact and non-contact forces. So contact forces include stuff like air resistance, water resistance, upthrust, friction. And non-contact forces include stuff like magnetism, electrostatic forces, and gravity. So let's start with non-contact forces. So non-contact forces are forces which do not require the two objects to be touching for the force to be there. For example, let's take magnetism. The magnet and, let's say, a paperclip don't need to be touching in order for the magnet to pull the paperclip towards it, right? Whilst on the contrary, contact forces, stuff like water resistance, air resistance, upthrust, friction, as I mentioned before, do need it. For example, if I rub my hands together, they get warm, right? That's because of the friction. That's because of the force of the friction becoming thermal or heat energy. And as you can see, the contact forces need the two objects to be touching. Now, I'd like to talk about two things now: weight and mass. Now, they might seem like the exact same thing, but it's very important to keep in mind that they are not. Mass is a measure of the amount of matter, the amount of stuff in an object that you're looking at. Take, for example, a 10 kilogram weight. There's 10 kilograms of mass, 10 kilograms of matter in that mass. But weight is completely different. Weight is the force of gravity acting on that mass. And weight is measured in newtons as opposed to kilograms, which mass is measured in. So let's say, for example, Earth's gravitational field strength, which is basically Earth's gravity, is a lot stronger than the moon's gravity, right? And because of that fact, I would weigh much less on the moon than I weigh on Earth, because of the fact that the gravity is less on the moon than on Earth. So the force of gravity acting on my mass is smaller. In fact, let's say I had a 10 kilogram weight that would weigh about 100 newtons on Earth, while that would only weigh 16 newtons on the moon. It must be important that you distinguish these two, weight and mass. That is, it's very important that you know what they are. Now I'd like to move on to 7Kb, springs. I'm sure we all know what springs are, right? Objects that can be stretched, compressed, and sort of have a coily shape, right? Now, springs are what we call elastic objects, elastic materials, because of the fact that once you apply a force to them, they come back to their original shape. As opposed to plastic materials such as Play-Doh, when you apply a force to them, that's it. They don't return back to their original shape. Now, there's a little thing I'd like to talk about here called Hooke's law. Now, I understand that anything with the word law in it probably sounds a bit intimidating, doesn't it? But in this case, it really isn't. All it basically says is that for every 1 Newton increase in the force, the spring stretches by the same amount, basically the same proportion, up until a certain limit called the limit of proportionality, by which point the spring changes shape. This is called Hooke's law. However, it is important to keep in mind that Hooke's law does not apply to all elastic materials. When objects are extended too far, what will happen is that they'll eventually reach their elastic limit. And as I mentioned earlier, they would deform, they would change shape. And after the force is applied, and once it's let go of, the shape would be different than it was before. Now, the final thing I'd like to talk about here is that springs are actually used in force meters because of the fact that with the extension of the spring, you can measure on the force meter how many newtons are being applied. And in general, smaller springs are used to measure smaller forces, and bigger springs are used to measure bigger forces because of the fact that bigger springs can take more force before they deform. Thanks for listening, everybody, and I hope you come back to learn a bit more physics next time. See you!